if you recall when we learned about functions, or when you've learned about functions in the past, whenever they put f of x or f of k or whatever the value is, we can always replace that f of x and treat it like a quadratic, okay? On the top of page 333, they tell you, you're used to seeing this. You've seen this before. Okay, so you've seen this, y equals, so this is a quadratic. Whatever the value of this gives you your answer, ax squared plus bx plus c. Now, another form that you're going to see this week, and they call this the general form, is the completed square. Okay, the completed square form, which will look slightly different. It'll be f of x is equal to okay, we've got our h's and our k's thrown in again. All right, the reason I'm showing you this is because what we're going to do with the quadratics that we're given is attempt to graph them and understand information about them, most of the time in this form, sometimes in that form, okay? So what I mean by this is you're used to seeing y minus k equals a x minus h squared, right? We've already seen this. This, if you replace that with y, is that, okay? Both of these. Oftentimes it's referred to as the completed square form. If I put a y here, this can become that simply by subtracting k. Let's look at example 1 and answer some questions. Now, I'm going to tell you one thing. It is super easy to make mistakes with these because of what they want you to do. Not because they're difficult, but just because you really have to concentrate until you really get good at it. Pardon my little scratch there. Okay. This is almost a blueprint of that right there. F of x, a coefficient or an a value multiplied by x minus something plus some other value. Okay? If I maneuver this 1 over to the other side and replace this with a y, I have this. And I have what we've already been learning about. Okay? Knowing that this can turn into what we've already been doing, which now we know the name of it, they're calling it the completed square formula. I can answer all of the same questions that I answered in the previous lesson. First question they normally are going to ask is, what is the axis? The axis is always going to be the h and k. And if you remember, it's y minus k, so if it's a positive number, here it'll be a negative, like that. It'll look like that. If it's a negative number, it would look like y plus whatever. So, interpreting this, I know this value here is a 1, and I know this value here is a 3. Okay? This is my vertex. My axis is where it gets cut down the middle. The x value, where it gets cut down the middle. My axis is going to be at a 3. And if I wanted to graph that, I could find more points. But just for sake of argument right now, I'm going to go over 3, up 1. That is where my vertex would lie. Okay? I could find more points, but you guys already know how to do that. So for sake of time, I'm just going to kind of keep going here. This is my axis, where it gets cut down the middle. See, we're not learning anything really new. We're just maneuvering things a little bit more. Okay, we're going to get a little bit more in depth with this stuff. Okay, so if I give you an f of x, replace it with a y, and attempt to maneuver until you have something times something squared, and this item here, bring it over here. We're going to do a few more just like this so that you kind of get the hang of it, so that you're not feeling like you're completely lost. I'm going to do another one just like example 1. This one is not in your book. All right, it's not in your book, so bear with me. Let's see. F of x equals 1. This is not in your book, so be copying this. Okay. Again, I have another equation that is not quite in the x minus h form that we learned about in the previous couple of lessons, but we can make it that way so that we can answer all the same questions we've been answering. Axis, vertex, and then we can plug in points and graph. If I take this and subtract it, and I turn that into a y, I get something that looks like this. Okay, so now it's in that form that we learned the other day. Y minus k ax minus h squared. When it's in this form, again, you can take the data you've been given and consider this item here. This is a -3, and that is a 1. Right there, I now have my vertex at -3, 1, which is real similar to that, isn't it? I didn't do that on purpose. Just picked another sample. -3, 1. There's my vertex. And if I started solving more points, I could find some other options to make the rest of the parabola. Okay? Like if I said, let's say a 1. 1 plus 3, that would be 16. What can I do to make a nice easy one? This is going to be a really wide parabola here. Anyway, you know what? I'm just going to keep going because I don't want to spend time. But we could find other points by plugging in values, solving for y, finding the mirror image. We've already learned that. Okay? Since it's such a small number, it's going to be really wide. All right. I want to go on to something else, though. Example 2. And we're going to learn a lot these next couple days about how to manipulate this, things that are kind of easy. Example 2. Show that the graph of, and here's what they give you, f of x is 3x squared minus 6x plus 1 is a parabola. Now, there's the easy way to do it, and there's the hard way to do it. They're going to teach you the hard way. I'm going to show you something a little bit different. So this is ax squared, this is bx, and this is c. Would you agree with me? You guys remember that kind of terminology? F of x, you can call that a y. They're not going to teach you this till example 4, but I'm going to tell you it right now because I think it's extremely helpful. Huh? Okay, you want to open the door? Oh, it's my...